from the GNU Linux users group and welcome to the third video of this reverse engineering series. In our previous video, we saw how using Ghidra can reduce our time required in debugging a binary. In today's video, we will continue our journey in Ghidra and see how we can solve level 2 and 3, which will help us in learning the basics and solid out our foundations. So let's start. Okay, so what we have here? Let's run our binary first and try out the level 2. So now it's asking us for a passcode. Let's give it some random value. As you can see again, the program is again asking for some passcode. Let's again put some random value. Okay, so as we can see that we are trapped in a infinite loop right now. So what's actually happening behind the scenes? To see that, let's load our program in the Ghidra. As we can again see, like in our previous video, that in between some if-else calls, some function calls are present like vault, trap, etc. And judging by the name of our level, we can guess that this trap function is being executed whenever we supply the level 2. Whenever we supply the integer 2 in our input. We don't have any logical foundation for this. We can check the decompiled output of this function by left clicking on it, and in that way we can cross check whether it's right or not. This type of brute forcing is sometimes allowed in reverse engineering as it can actually save some time in comparison to actual analyzing of the logic. So now as you can see over here, the function is printing some statements like enter passcode, infinity trap, which as you can remember were printed while we are playing our level. So this proves our assumption that this function is executed whenever we played the level 2. So now what? We narrowed down our function, have the decompiled code right in front of us, and as you can see, this printf statement is present inside a while loop. This explains the infinite fashion of the program. But a while loop must have an exit condition, right? So what is it? As you can see, this loop runs until this local 1D variable is equal to this null terminated character. This explains why once the program enters the while loop, it keeps on printing the message in an infinite fashion. But we can see over here the value of this variable is set to this null termination character. But we can also see that this statement is within an if statement. This means this local 1D variable will be converted to this character and we will be pushed out of the infinite loop only when this condition is true. So let's check out what it is. Okay, so it's checking whether this ivar1 value is equals to 0 or not. And as you can see in the previous line, the ivar1 value is set equals to the value written by the string compared function. Okay, now if we see the man page of string compare function, we can see that string compares takes two strings as inputs and returns a value of 0 only when both of those strings are equal. Makes sense, right? Let's get back to our Ghidra tab. Now you guys can see that the string compare function is taking two variables as input, this local 88 and this local 30 variable. Let's see where we can find them in this program. Okay, so as you can see that this local 30 variable is storing the string dil mange more. And moreover, this local 88 variable is taken as input from the user through this fgets call. There is also a bunch of code in between these lines, but as we learned in our previous video that we should always focus on the important code segments rather than on the code as a whole. So what we know so far is that our code is taking an input from the user and is cross-checking it with this dil mange more data, and if it is equal, we may be able to get out of this infinite loop. Let's try it out. Okay, so let's enter the string dil mange more. Oh, we are asked for another string for granting full permissions. So now we overcame one of the obstacles in the program, but it requires one more input from us to fully grant us the access. So without any delay, let's switch back to Ghidra and see what's actually happening. So we are back at our decompiled code, and as you can see, after this program prints this statement, give me all the letters to unlock the permissions, it takes an input from the user using this fgets call and stores the data in this local 68 variable. But as we remember from our last video, it is sometimes easier to analyze the functions from the back than from the top. So let us approach the solution in that manner. So we can see at the end, the program chooses from either of these two functions, success or fail, and runs either one of them based on this condition. But what are these functions exactly doing? Let's start analyzing, starting off with this success function. As you can see over here, there are a bunch of if-else statements, a printf statement that is printing the statement already solved. Okay, there's another put statement that is printing some data. But what is this data? Let's see if anything happens if we click over it. Okay, so as you can see, this data is storing the string access granted, which is printed whenever we supplied the correct string, right? So this function must be executed whenever we supply the correct string. So let's get back and backtrack our solution. Okay, we can see this success function is executed when this local 1c function is equal to this hex value. Now Ghidra allows us to convert data into any format simpler to us. So let's change this value to decimal. Okay, so 777. Now we have to see how the value of this variable local 1c changes in the program. Before doing so, since we will be dealing with this variable, its large name makes it harder for us to work with. Let's change its name to a simpler one. We can see here that this line modifies the value of I in each iteration of the while loop. Let us first see what are all the variables associated in this line. We know that this local 68 is a pointer to the string we supplied. But what is this local 24 variable? As you can see over here that this local 24 variable is initialized to 0 before entering the loop. But we can also see that the value of local 24 is incremented by 1 at each iteration of the while loop. If we see over here, the loop will break when the UVR2 variable will become equal to or lesser than this UVR3 variable. And in the previous line, we can see that the value of UVR2 is set equal to the length of the string we just supplied. String length is a function that returns the length of a string in C. But hang on, we can also see UVR3 is made equal to this local 24 variable. This sext function is nothing but some inbuilt type compatibility function used by Ghidra. So you just think this of as an equate operation. This makes it clear. The while loop iterates the value of this variable local 24 from 0 to 1 less than the length of the string. And if you look over here, you can see that this line is basically adding 0 or 1 or 2 to the string pointer and taking the character at each position. So what this loop is basically doing is looping over all the characters of the string and summing their ASCII value and storing that value in this variable I. Okay, so we now need to find a string whose ASCII sum of the characters equate up to 777. With a little bit of brute force, we can find the ASCII value of this character O is equals to 111. So a string containing 7 O's will probably equate up to this value. Let's try it out. Oh wow, we are granted the access and we successfully solved this level. Okay, let's try out level 3. As you can see, we are presented with an access denied screen. So without wasting any time, let's load our binary in Ghidra. Let us iterate the same steps we did during solving our last level. Doing so, we found this illusion function. Let's open it. Okay, we can see this function after printing some output that we saw in our level is trying to open some file. Now we know that if open return a stream operator, and this line of code over here is trying to check whether this file contains some data or not. Basically, it means it checks whether the file is empty or not. And if it's empty, it's calling the function no. Let's check what this function contains. As you can see, this function is printing some data in the screen. But what is this data? Okay, we can see this data is access denied. So this function is responsible for that irritating access denied window. Let's get back to our illusion function. Okay, now that we know that no function will be executed whenever there is no file named illusion.txt or an empty file, so let's create one with random data in it. Okay, since now we have created our file, let's rerun our level and see what happens. Okay, so it gives us the access without any hurdle at all. All it required was some text file with some arbitrary data in it. In today's video, we saw how we can analyze different functions and data present in a binary using Ghidra. But sometimes Ghidra alone is not that much helpful in analyzing a binary. Then dynamic analysis using GDB comes into play. We'll see this while solving our level 4 in the next video. Till then, thank you.
Back from the dead.